Am I audible?
Yes, sir.
Okay. Then today we will see another algorithm of unsupervised learning. So first we have seen supervised learning algorithms in the previous classes. So now we will see what are the unsupervised learning algorithms. So before proceeding, I would like to tell about the unsupervised machine learning. In supervised learning, the models were trained using label data under supervision of training data. But in unsupervised machine learning, we do not have label data and we need to find the hidden patterns from the data set. So supervised versus unsupervised machine learning algorithm, we can tell that the input data is labeled in supervised learning, whereas it is unlabeled in unsupervised machine learning. The computational complexity is simpler in case of supervised machine learning, whereas it is computationally complex in case of unsupervised machine learning. Also, the accuracy is highly accurate in supervised machine learning, whereas the accuracy is lower in unsupervised machine learning. And the algorithms already we have seen in the supervised machine learning. So today we'll see the algorithms which are coming under unsupervised machine learning. So as the name suggests that it does not need any supervision to train the model. And the data set we are taking for training is unlabeled. That's why it is called unsupervised learning. So one example I would like to tell that suppose we have input data set containing images of different types of cats and dogs. So the algorithm is never trained upon the given data set, means it don't have any idea about the features of the data set, how the cat look likes, how the dog look likes, what are its attributes we don't have. So the main task of this algorithm is to identify the image features on their own. So how it is done? It is done through task of clustering the image dataset into groups according to similarities between the edges. So basically, it is helpful for finding the useful insights from the data, and it is much similar as human learns to think by their own experiences, which makes it closer to the real AI. So in real world also, we do not always have input data with corresponding output, so that we need unsupervised learning. So under unsupervised learning, it is categorized into two types of problems. I will write here. Hope you are able to see my screen now. Are you able to see it? Just type yes if you are able to see and type no if you are not able to see so that I can know. So we have clustering and association in supervised learning. So what is clustering? It is a method of grouping the objects into clusters such that the objects with most similarities remains into a group and has less or no similarities with the objects of another group. Basically clusters like These are clusters. It is having some input data like this to cluster 1, 2, 3, like that. It will be having clustering. Whereas in association rule, it is used for finding the relationship between variables in the large database, and it determines the set of items that occurs together in the dataset. Suppose people who buy X item, suppose a bread, and also tend to purchase Y item, suppose it's butter or jam item. So the typical example of association rule is the market basket analysis. So there we will see how these two we can use to find out and do the prediction. First, we will see the clustering algorithms under unsupervised learning. First one is your k-means clustering. Under clustering, so it basically groups the unlabeled data set into different clusters. And the k-means clustering assigns the data points to one of the k clusters depending on their distance from the center of the clusters. So it starts by randomly assigning the clusters centroid in the space. This we will see with a simple example how we do the clustering. And also it runs iteratively until it finds good cluster. One example I will show you under k-means clustering. Suppose we make two clusters, K1 and K2. Some unlabeled data points we have here in cluster K1 and K2. So our task is to assign the data we are now having in K1 or K2. How we will assign it? This we have customer number, age of the customers, and the amount. How much the customer is spending. C1, C2, C3, C4, C5, C6, C7. And their associated weights are, ages are 40, 30. The amount they are spending. This data we have actually, and we don't know how we can cluster them. So we will be clustering randomly first. We will assign K in cluster K1 as C1 in K1 and C2. This we will take randomly in cluster K2. So here C1 is having this data points 2500, C2 is 40 and 1000. Then next, how we will assign the customer tree. So we will use the Euclidean distance formula. I've already told you with the distance finding we can do the clustering. This formula is square d is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So here is our observed value. This is centroid value. And similarly, this observed value. So for C3, we will directly apply this formula. T minus 20 whole square plus this data I am taking from here. This data. C3 value already here it's mentioned 30 and 800. Directly we are taking first difference between the value of C3 and C1 plus the difference between this values of C3 and C1. We will have to determine whether it will come under C1 under cluster 1 or cluster 2. So that's why we are first taking C1. Comparing with C1, the C3 we will get after solving all this. Directly I am writing the calculated value here. And also we will calculate this with C2 data points. So solving this, we will be getting value like this, 300 and 200. So what we can conclude from this, we will put it in C1 or C2. this value is less than this 300. So this is less. And this is more coming towards C2 in cluster 2. So we will put this in cluster 2. C3 will come in cluster 2. So now we have to update the centroid. For that we have to calculate the mean of the centroid, which is C2, it was 40 and 1000. So we will write this as mean of C2 and C3, 35 and amount values, the mean of amount values of C2 and C3 would be 900. So now we will be updating this. It will become like this. C3. So similarly we will calculate for C4 using the same formula. We'll just put these values over there and we'll solve. So it may be over 4 plus. So this we will calculate and get some value. This we will calculate with C2 similarly. I will come up with some value. So I will not calculate, just calculate what's the value. So it will be inclined more towards C1. C4 will be inclined more towards C1 in cluster K1. So in K1 we will put C1 as C4 and then we will update by using that mean of the centroid. So C1 was having this value 20 and 500. After calculating the mean, we will get to like this. Cluster K2 it will be only C2 900 C3. Here we will put C4. So I will not calculate every data. So you just follow these steps and just calculate for the other till C7, and you will get the clusters based upon that where these will lie. I've shown you the way how it is done. So similarly, it will be calculated like this, and the cluster will be having these data points. So it is a way how we will do in Python. Also, we will see how we can do this and how this will do the clustering and all. It was just the mathematical way how it is done internally. So I have shown you this basics. You have to see how it works. We'll see after that how it will be working with some real data. So now moving on to next clustering, it's hierarchical clustering. So it is basically connectivity based clustering model which groups the data points together that are close to each other based on the measure of similarity or distance. So here the assumption is that the data points are close to each other, are more similar or related than the data points. Here we will make a tree-like figure called dendrogram by hierarchical clustering that depicts the hierarchical relationship between the groups. So basically we will see about the hierarchy of the data we are having. Suppose in case of e-commerce website, so there we are finding we are having some data in clusters. How we will be making those clusters? Suppose some customers are spending on electronics, some are spending on clothing, some are spending on grocery. So based upon this, we can prepare the clusters. This one cluster. This is another cluster, and this is third cluster. So here also two types of hierarchical clustering is done. One is your hierarchical agglomerative clustering, which is a bottom-up approach of hierarchical clustering. Here the structure is more informative than the unstructured set of clusters written by flight clustering. So it does not require to pre-specify the number of clusters, and it treats the data as singleton cluster at the outset, and successively it agglomerates pairs of clusters until all clusters have been merged into a single cluster that contains all the data. This we will see with a simple example. Suppose we are having one-dimensional data points. Which are 1, 5, 8, 10, 19 and 20. So out of this, we will see the relation between this cluster and how we will proceed with it. We'll see the least distance between which data point. It is 19 and 20, which is 1. So we will make it one cluster like this: 1, 5, 8, 10, 19, and 20. Together it will be in one cluster. Then similarly we can proceed with the other values. So between 8 and 10 it is, the difference is 2. So now we can take this in one cluster: 8 comma 10. Then next would be our difference between 5 and 8, which is 3. So together we will put it in this cluster. So it will be reduced like that. 5 and 8 and 10 will be together. We are just reducing these data points through clustering. Then we are having like this. So next will be between 1 and this data point. And finally, this whole one will be put with this. So finally, after putting those data points into clusters, we have put remaining this one and this one together, and we will be getting the dendrogram like this. This is all called dendrogram. So this all we will see with how through Python we can do. Just you see the way how it is done with different clustering algorithms. So you are seeing that it is a bottom-up approach. From here we are getting finally to this stage. To this stage we are getting. So it is a bottom-up approach. Next, I have told you about the hierarchical divisive clustering. So it is top-down approach. It is just opposite of the bottom-up approach. And this algorithm does not require to pre-specify the number of clusters. So it requires a method for splitting a cluster that contains the whole data, and it proceeds by splitting clusters recursively until individual data have been split into singleton clusters. This we will see divisive clustering is done. Stop down. With the same data points we will proceed. So it will be done in this case. So we are just splitting this into 19 and 20 together into one cluster, and 1, 5, 8. Then we'll put in another cluster. Then again we will split this. We will get like this. Splitting this further. Finally we will be getting like this. So this is how the divisive clustering works. I have just shown you with simple data points how it is done. Next we will move on to another algorithm, which is principal component analysis. So it is also an unsupervised learning algorithm used for dimensionality reduction, and it is a statistical process that converts the observations of correlated features into set of linearly uncorrelated features with the help of orthogonal transformation. So this we will see with a simple example how it is done. So here we will be doing the dimensionality reduction. From 2D to 1D dataset. Suppose we are having one dataset here, features D1, D2, D3, D4, just as X1 and X2. So some data we are having is uh, 4, 8, 13, 7, 11, 4, 5, 14. So how do we apply this PCA for this particular set of data? First of all, we will calculate the mean as x bar of x1. So we'll be having 4 data. So calculate the mean like that. Then x2 bar so we have got the mean value here for x1 and x2 features. Then in step 2, we will compute the covariance matrix as S equal to covariance of x1 comma x1, then curve x1 comma x2, then curve of x2 comma x1, then curve of x2 comma x2. So covariance of x1 and x1 would be 1 by n minus 1. Summation goes from k equals to 1 to n x1k minus x1 bar into x1k minus x1 bar. So since we are having only 4 data here, we will write 1 by 4 minus 1, and I will be putting this value here. 4 minus 8 whole square plus 8 minus 8. Just see the values how I am putting from the table. Here x bar already, x1 bar already I have created in the first step, so that's why I written 8 here, and for x1 d1 will be your 4 plus next data d2 is 8 in x1 bar, then d3 is 13, then x1 bar 8, d4 7, and x1 bar 8. This after calculating this, we will be getting the value like this 14. So curve of x1 comma x1 will be 14. So for this covariance matrix, we will be calculating for all the values. Curve of x1, x2, we will be calculating this like the previous one only. I will just write the value here. It will be just similar. We will have to consider the values of x1 and x2 and the x1 bar and x2 bar values. Here we will be getting the value as minus 11. Then similarly for this x2 and x comma x1, it will be just similar with curve of x1, x2. It's minus 11. It will be similar x2 comma x1 or x1 comma x2. And curve of x2 comma x2 we will have to calculate. It will be coming value like this 23 after all the calculations. Just we have to change the value of this and this. If it is written x1 and x2, then first we have to write x1k and x1 bar. Then we'll have to change this for this x2k minus x2 bar. Just we have to change like this. First one we will consider this. Second one for this, we'll consider this. And For each, we have to calculate using this formula, and we will be getting the values like this. So finally, our covariance matrix should be is equal to 14 minus 11 plus 11 and 23. Then in the second step, we have to calculate the eigenvalues of the covariance matrix. This step 3. So here we will write as 0 equal to of lambda I. So it is the characteristic equation of covariance matrix. I is the identity matrix, which should be like this: 1, 0, 0, 1, and for x lambda it would be like this. Just multiply lambda with each of these values. This way we'll get like this. Now for calculating this, we will write it like 14 minus lambda. And here already minus 11 was there. Here we will write minus 11, which was already there, and 23 minus lambda. Just applying this formula. And we will calculate it.
Yes. Zaman saya boleh registration itu di nomor kubur sih. Ini udah mana mau?
Okay.
Ini udah. Oh. Ini kayak nama bahasa mana lah?
So it's a quadratic equation and it will come like this after solving. We'll just try to solve this. We'll be getting the equation like this, which is a quadratic equation. This will be equal to 0 on the equation only. So we will solve it like this. The quadratic equation form.
138 and 101. This thing that is mine. Apart from that, I have shown you that those IP addresses. That I will show. Someone will log in and I will show you now.
Equal 1 b equal minus 37 c equal to 01.
4 to 6 IP addresses. I showed you.
So lambda value equation, we will put these values.
These two IP addresses, he assigned you. Now what is the point? Now you tell me how it was. Maybe that might once happen because they are changing the IP at the hardware stage. Now what is the thing that you were telling me it was clean? It was clean, it was interrupted. It was our last word. No, what I am asking. You told somebody that
Solving all this, we will get the value like this.
Then I'll show you.
Our lambda will be 37 plus square root of 565. This I will not tell you, just go through it, how we can solve this quadratic equation.
In the morning, you said that no system is having
We are
that
getting
access,
this value
but
finally,
fortunately, one system is having that Jyotima is using. And another thing that
plus and minus
two
value.
IP addresses I am having that are assigned to me.
So now we will compute the eigenvectors.
You are telling like these two are suspicious. The job has failed. Now in the past, when did you submit the job? This is super yesterday.
Which will be u equal to u1
I informed him that
and u2.
that moment what I am asking.
So it will be like this,
You want the
0
calculation
and
for
0.
that? No, I am asking about yesterday. It was like that. Today, yesterday, you have written that. Yes, I have written. I write
Lambda
out
I
more also
into
because
u.
it, the thing we create then also. Then I know why you have to create this thing. I am not creating. I don't know who is logging. That is what the thing. Now I am asking like you are telling 37 the problem. I shared this snapshot to Vaikunda Mani and this is showing 102. Who is 102? Please tell. No. This is when. When is not the case. When this is now this what is I am asking. This is of 17 September. Now what I am asking is yesterday you have written. Yesterday it was here. As per your whatever you have submitted. Right. Yesterday what was. But before that it was still I didn't report it. This also is no no. Keep this in mind. हम लोग का लाएंगे ऐसा नहीं कि स्टैटिक मतलब क्या होता है वो कुछ कोऑर्डिनेट इंस्टॉल किया है ना तो उसके लिए मतलब पहले जो आईपी था हम लोगों का सब चेंज हो गया अब कब चेंज हुआ है कब चेंज हुआ जब वो मतलब वो लोग चेंज करते रहते हैं फ्रीक्वेंटली करते रहते हैं हर महीने नहीं मतलब वो जब कुछ प्रॉब्लम आता है ना तो चेंज करना पड़ता है इस सितंबर 102 कौन किसने करा कौन लॉगिन हो पार्वती करे हमने पूरा दिखाया
So to
इस लॉगिन हुआ है लास्ट लॉगिन दिखाते हैं हमने
equations will be getting from this is
what yesterday you were telling like you were
one is this and one is this.
And you are telling there was a suspicious activity which pertaining to the
But we will take this.
I'm
We
not
will
telling
be
any
not
story.
taking this u2.
I am telling the
We are
fact of
taking
truth.
this value
Okay,
only.
this is the IP address and I shared my I'm not telling any story. I'm not telling about this one. Yesterday it was fixed. So this is of division only. As per his statement, the big word. What I am asking, you are not understanding. That question you please address.
Well, T say.
I'm not jumping. I'm just telling you that some IP addresses are coming into picture that are frequently logging into the different servers. That is yesterday you written a very strong message. Like somebody
So
is
u1 will be 11t.
Now that's what I'm asking regarding that one.
And u2 is
Today morning also you told.
lambda t.
Hold on. Some X person is visiting. I have written. Please read the statement. What I have written. So then that some X person is either 101 or 134. That's our understanding. Now he has rectified both are your IP. Then now who is the X? Who has in
The lambda 1 values were
no, that last value only we have checked, right? Only constantly 101,
lambda 2 value.
134 is mine. That is Wi-Fi one. One is Wi-Fi, one other is IP LAN. No, that's what I am keep on asking. What if the third IP address will come then? What will you answer? Okay, what third? You are just see. First you will stick to 1 to 1 or 1. That is fixed. That is fixed. That is right. Then he right one that.
So we'll be calculating only one principal component out of these two. So we with the length of u1.
They keep changing something, and they are not answerable to us. Okay, they are working in the institute. So whenever they are doing something, I'm not telling like everything that they will inform like okay your IP starts from here and your IP is up to here like that they will not inform to us. Why they are not giving the information? Can't we ask them what are the IP addresses that are assigned to us? We are assigned 12 series, na? 10 series is outside. That is very well known.
So lambda 1 is value is 30.3849
Who's that? Who is that
score.
department? अभी तो उनका सेल्स नहीं करते, अभी मतलब अभी आपका सेल्स नहीं होगा। वही सितंबर में जो दिखा रहा है 102 का, ये कौन था? हमको तो नहीं पता कौन है। 102 आप एक बार देख लीजिएगा। एक नहीं, अभी हम अपनी लैपटॉप में खोल के पूरा हमने वर्ड
So the V1 is your 19.738.
मंथ वाइज सारा डिटेल का पहले तो यूज कर रहे हैं सितंबर में तो बहुत लोग, अक्टूबर में 2 महीने
Now the eigenvalue or the eigenvector for lambda 1 will be
1 to 2 it may be your desktop also can say 1 to 2 it is plugin
V1
plugin है तो एक बार plugin करके देख सकते हैं 1 to 2 है तो
11 divided by
तो मतलब अभी कोई एक्सेस नहीं कर रहा मेरे हिसाब से, मतलब मैं देख रहा हूँ
U1
पूरा स्कैनर आपने देख रहा है
3 minus lambda 1 divided by U1.
को लग रहा है कि एक्सेस कर रहे हैं, मेरे हिसाब से नहीं है क्योंकि हिस्ट्री में आप ही दिखा रहे हैं, वही मैं कह रहा हूँ हिस्ट्री में सब क्लियर है, मेरे बोलने से कोई ना आप सब कुछ दिखाएगा, मेरा दिखाएगा लैपटॉप मेरा दिखाएगा, आपका आप दिखाएगा, आप उसमें कोई कुछ कर थोड़ी सकता है। नहीं मतलब 1 1 1 को दिखा रहे हैं रिसेंटली, मतलब आप एक काम कीजिए अभी सबमिट कर दीजिए, अभी 1 को 1 नहीं हुआ है ना, तो मतलब 1 तो मैं देख लूंगा ऐसे आप पहला क्या if you find any more different IT then you check. Sure, I'll let and maybe you can check also with this desktop also.
Divided by
Of that desktop.
97348.
That will be having
So
only
finally, after calculating, we will be getting the eigenvalue as E1 equal to 0.5574 and minus 0.8303. Similarly, we can calculate the value for E2, but here only we will take the value of E1. So the first principal component, we will calculate it like this. Transpose of E1 is x1k minus x1 bar x2k minus x2 bar. So transposing this, we will get like this for D1. x11 x21 minus x1 bar minus x2 bar.
That is having 170 actually desktop. I've shared in that.
After calculating this, we will be getting the value as minus 4.30535. So for D1, we have calculated the first principal component, and like this only we will calculate using the E1 transpose and the matrix, like just like the previous we have used. So just it will be changed here. For D2 we will take x1 2, then x1 bar we will take, then for feature 2 we will take x2 2 and x2 bar. This we will be putting all these values in this equation. We will be getting the principal component value like this for every features. Next to the principal component values. This we have already calculated. Then after calculating similarly, we will get the other first principal component value. For all the features and for all the data values d1, d2, d3, d4. Finally, we'll be getting the values like this. Will be fourth value will be minus 5.1238. So after all this, we have to make the geometrical meaning of the principal component. Step 6 is geometrical meaning of this principal component. So E1 value was we found it is so one is positive, one is negative. This we will put in the graph. X1, X2, so x1 and x2 from the table we will be putting the data points over this. First was for x1 is for d1 it's 4 and x2 for d1 is 11. 4, 11 we would put here. Somewhere here it will come. Then 8, 4 for d2. 8, 4, and then for D3 it's 13 and 5, and 7, 14. Somewhere around here it will come. So somewhere around here we will be getting the mean. We assume it as 0 and 0. So next, this way we'll straightly extend one line, and here straightly we will extend one line. And also E2 will be like this only. So for E1, one value is positive. It will go uh, one value is positive in E1 and one value is negative. So it will be around here. And we will straightly pull one line here for E1, and for E2 both the values are positive, so it will be somewhere around here from 0. We will put one straight line here for E2. So finally we will be getting the geometrical meaning of the first component analysis like this for both the values. So our mean was here. So E2 value we were getting, so this will be straightly we will put here like this. Just match with the coordinates here. I'm having difficulty to draw exactly. So if you draw it correctly, then it will come like this only. It will come. This was E1. So our coordinates were lying like this. It's going actually here and there, so just try to put in a proper manner, then it will come. And this we will project it towards it. This point will project towards it, this will project towards it, this will project towards it. So basically it will come in one dimension. So we have reduced it into one dimension. We are finally getting this into this form. So it is linearly presented. That's how the principal component analysis work. So any doubt till now?
G. So first draft by consideration.
If anyone having doubt, you can ask.
Then conclusion part. Discussion.
Just try to practice it, and this is how the algorithms work. So after that, we will be seeing how it can be done into the data sets and how in Python we can do it. So if you are having any doubt, then you can ask. Otherwise, we will conclude here.
Sir,
Yeah.
sir, I don't have any question in today's class. Actually, I was absent in Wednesday's class. So
Okay.
can you please tell me on which topic you have discussed on last class?
So in last class, I was discussing about the ADA boost. So that note I will share in the group. You just see over there.
Okay,
Yeah.
okay, sir. Thank you, sir.
Yeah. Any more doubt? Or you can just type it in the group also if you are having any doubt.